Alright, so the next question here is, when calcium oxide is heated with carbon, the oxide is converted to what? B converted to carbide, B converted to triazocarbonate for salt, D decomposed to metal, C decomposed to metal, D melt producing carbon dioxide. So let's see, when we have calcium oxide reacts with carbon, we have calcium carbide plus CO. It releases carbon oxide. All right, so looking at this equation, we need to balance it. We have this balance. So looking at this equation, we can see we need to balance it. So yes, it's balanced. So we have for carbon here, we have 2 plus 1, that's 3. 3 here, calcium, the equation is balanced. So when calcium oxide is heated with carbon, the oxide will, so what do we have? Calcium oxide reacting with carbon, we have calcium carbide plus CO. So looking at this is calcium carbide. This is a carbide that is formed. So from this equation, you can see that a carbide is formed, and that will refer us to the option. So looking at the option, we have option A, be converted to carbide. So we see calcium oxide plus carbon gives us calcium carbide. That means a carbide is formed. That means option A, be converted to carbide, is the correct answer. Alright, I hope we are following and we are understanding the question. So question 19, a solution which on treatment with hydrochloric acid produces colorless, odorless gas which turns lime water milky is mostly likely to be A, triazonitrate 5, B, chloride, C, triazocarbonate 4, D, hydroxide. So a solution with treatment with hydrochloric acid. So mostly triazocarbonate 5, triazocarbonate 4. When reacts with hydrochloric acid, it gives CO2. It gives CO2 and chlorine. So is it balanced? So when triazocarbonate 5 reacts with hydrochloric acid, it gives CO2. That's the odorless gas. So when this odorless gas, CO2, when CO2, okay, plus chlorine gas, sorry. So this is balanced. So triazocarbonate 4 plus HCl will give CO2 plus chlorine gas. So when this CO2 reacts with lime water, calcium hydroxide, so what will it give? it turns lime water milky. That's where we have
Get the cheapest science materials from allschoollabs.com.
CaCO3 plus H2O. So this is lime water and this is the milky substance that is formed. So I'm just trying to verify the answer that triisocarbonate 4 is the correct answer. You say triisocarbonate 4 is the solution when treated with hydrochloric acid. You have CO2, which is the odorless, colorless gas. And when this CO2 reacts with lime water, you have this milky substance. So it's as clear as that. Alright, so the next question, question 20. The soft solder used for welding and plumbing is alloy of, what is an alloy? Is a mixture of metals. So which solder is used for welding and plumbing? The correct answer is lead and tin. Option A is the correct answer. So the reddish brown, that's question 21. The reddish brown rust on iron roofing sheet consists of the iron roofing sheet, that brown color on iron roofing sheet when water, which results as which occurs as a result of corrosion. So what is that reddish substance? That is iron 3 that is there. So this is the correct answer. Iron 3 oxide with 3 molecules of water. Option C is the correct answer. Question 22. In this question, we have an equation that is well written and balanced. So, and this is a reaction that is taking place here. So the option, we have factors that affect the rate of reaction. So we have to deduce which of these factors listed here is correct. So A, an increase in temperature and decrease in the concentration of the reactant. So with this statement, will it affect the rate of a chemical reaction? No. An increase in temperature and decrease in the concentration of the reactant, is it correct? No. A decrease in the volume and increase in the pressure of the reactant, is it correct? No. A decrease in temperature and an increase in the concentration of the reactant. D, an increase in temperature and an increase in concentration. Once temperature is increased in a reaction, no, it makes the reaction to be faster. It affects the rate of reaction. Also, when the concentration is increased, there is also increase in the rate of reaction. So this statement is correct, it aligns well compared to the other statements. So an increase in temperature and an increase in the concentration of the reactant will affect the rate of this reaction. So the next question, question 23. The tincture of iodine means iodine dissolved in. So here, the tincture of iodine, which is used in hospitals, the iodine solution that is used as an antiseptic. So it's dissolved in what? It has alcohol in it, which is ethanol and water. So it's dissolved in ethanol and water. That is why the ethanol, that is why it's mainly used as an antiseptic. So option A is the correct answer. Question 24. This is an equation. In this reaction, what is the effect of precipitating copper as this, right? So what is the effect? What is the implication when you precipitate copper as copper sulfide? What's the effect? So what will happen? This equation is a reversible reaction, we can see. But in a situation when you precipitate copper with this copper sulfate, what will happen is the effect is that the reaction will shift, equilibrium will shift to the left, to this side. And what will happen as a result of that? There will be more production of ammonia. That's what will happen. So let's look at the option. Ammonia concentration will decrease. More ammonia, the equilibrium will shift to the right. There will be no effect. So from my illustration, I said the equilibrium, you can see from this side, it shows that there's an equilibrium. So the equilibrium will shift to the left side and there will be more production of ammonia. So that makes option B the correct answer, more ammonia. So question 25. Copper and silver metals are commonly used as coin because they are. Why do we have coin that are made with copper and silver metals? Why not other metals? So why did they use copper and silver? One, because easily reduced, not easily reduced, easily oxidized, not easily oxidized. It is not easily oxidized. It cannot get rust easily. That is why they coat the coin with copper and silver. So D, not easily oxidized, is the correct answer. Question 26. Which of the following set of metals dissolve in HCl? So which of the following set of metal dissolve in HCl? So we have this: iron, tin, and copper. Magnesium, iron, and copper. Magnesium, tin, and iron. Copper, magnesium, and tin. So the correct answer here is option C. So these metals does not readily dissolve in hydrochloric acid. All right. So the next question, question 27. If chlorine is bubbled into water and the resulting yellowish green solution is exposed to bright sunlight for a while, the solution decomposes, giving out what? So when you dissolve chlorine, you bubble chlorine in water, it gives the yellowish green solution and you further expose it to sunlight. So the solution, what will happen to the solution? Up from the options here, option D is the correct answer. So the solution will decompose by giving out oxygen, thereby producing hypochlorous acid. That's hypochlorous. Yes, this. So the solution will produce this hypochlorous acid. So that is what will happen. Option D is the correct answer. Question 28. The reaction that takes place in Daniell's cell is, in Daniell's cells, we have charges. So the reaction that takes place, we have the reduction, oxidation takes place in the Daniell cell. So let's look at the option. We have direct combination, B redox, double decomposition, neutralization. So in Daniell cell, we have redox reaction, that's oxidation and reduction. That's what's called the redox reaction. Option B is the correct answer. Question 29. What happens when zinc ion is immersed in copper 2 tetraoxosulfate 6 solution. So when you dip zinc rod into copper 2 tetraoxosulfate 6 solution, what happens? A, the blue color of the solution disappears. B, electrons flow from copper to zinc. D, C, the zinc rod remain undissolved. D, the copper generates more copper ions. So when you dip zinc rod, copper solution, because copper has blue color, so the solution is blue. So by the time you dip zinc rod into that solution, the blue color disappears. So that's what happens. So that means option A is the correct answer. The blue color of the solution disappears. Question 30. How long would it take to deposit 0.08 gram of copper from copper chloride solution by passing a current of 0.
Run quick tests and analysis. Visit analysis.africa.
5 ampere. So we have to calculate the time in minutes. So let's start. Let's start with this equation. This is what we have for the copper. Yeah. So we have this equation. Looking at the parameters, we have 1 Cu, which is 64. We give this charge 1 Faraday. That's 9,6,500. That's what was given. So from our equation now, we have 1 copper. This our copper ion with 2 plus. Give 2 Faraday. This is the charge. This charge. So let's calculate. If 64 we give this, that means 1 copper, this 64 we give, since we have 2 charge here, that would be 2 times 9,6,500. So let's calculate that. 2 times 9,6,500. We have 193,500. So that is what we have here. So let's calculate. Okay, how long will it take to deposit 0.8 gram? If 64 gram, so let's calculate it. If 64 gram, so I'll be raising this part. You've noted the equation. So let's answer the question now. We've calculated our copper. Since from the equation we have 2E and we've multiplied 9, this what Faraday that was given, we multiplied it by 2 to get 193,500. Okay, so if 64 gram gives 193,500, how many charge will this 0.08 gram give? We don't know. So let's do our calculation. Cross multiply. 64 times x equals to 193,500 times 0.08. 193,500 times 0.08. That will give us, okay, that will give us 15,440. This is 64 times x will give us 64x. To make x the subject of formula, divide both sides by 64. Both sides by 64. So we have x is equal to this divided by 64. So we have 15440 divided by 64. So we have, if you press your calculator correctly, you have 241.25. So this is our charge represented as this. So, but we are not stopping here. We have to calculate the time that it will take to deposit. You already know the charge that will take to, that will give, that 0.08 will give. So, but how long will it take to deposit this? So from our calculation, from the equation, we have our Q is equal to current times time. And remember, this time is in minutes. So, but this time in this equation is in seconds. Our Q is what? 241, what we calculated here, 241.25 is equal to, the current is 0.5 times time. So what we just need to do is to divide both sides by 0.5. So we have 241.25 divided by 0.5. So press your calculator to give the correct answer. So we have, our time is 482.5 seconds. So we are not stopping here, because I said earlier that this equation will give our time in seconds, but we have to convert to minutes. So 60 seconds equals to 1 minute. So this seconds, 482.5, we give how many minutes? So we have, what to calculate this in minutes, what we just need to do is to divide this by 60. Divide that by 60 and you get 8.04 minutes. So this is approximately 8 minutes. So from our option, we see that option B, 8 minutes, is the correct answer. I hope you are following. Don't forget to subscribe, like and share. Okay, question 31. Tartaric acid is used industrially to, tartaric acid, what is the use of tartaric acid? Is it to make baking powder, to make fruit juice, to make rust, to dry substance? Tartaric acid is used to make baking powder, and its reaction liberates carbon dioxide, which is when you have this soft and fluffy baked cake, baked bread, and the likes. So tartaric acid is used to make baking powder. All right, so that's the correct answer, option A. Question 32. The salt formed from strong acid and strong base. Remember, we discussed about it.
Hi, I'm sure you enjoyed the video you just watched. To see more content as that, preparing you for your upcoming exam, make sure to smash the subscribe button and turn on notification. Also, remember that you can use the comment section to send us your questions or your inquiries, and we are happy to take them. I'll see you in the next video. Bye.